The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. Think of this show in this way. Rush Limbaugh and Howard Stern had a child, and that child grew up to have a podcast about building science. This is the opposite of that. Here's Bill Spohn.
Welcome back to another episode of the Building HVAC Science Podcast. We're out there, really inside your head, in your ears, trying to help create a better, more knowledgeable HVAC and building performance world by educating technicians, by connecting goals and desires, by educating the best we can and sharing the knowledge that we have. I'm going to do a little reversal here today. I'm going to start out with the quote that I usually close with. The quote's from George Carlin. May the forces of evil become confused on the way to your house. Would a no better or more apropos quote for today's topic. Yep, we're talking about radon. Radon is a force of evil. It's pure evil. It's colorless, odorless, deadly, but it's sneaky deadly. It's deadly over decades. So today we have on the podcast my good friend, Dick Kornbluth. He's joining me to unravel the intricacies of all aspects of radon, this colorless, odorless, poisonous, radioactive gas. He's going to tell us where and how it's formed, how it gets into the air we breathe, and the health impact that it has on us. He's also going to give us a little insider information, talk about that famous 4 picocuries per liter exposure amount that you hear about an awful lot. So Dick will share his experience with us, and I think you'll find this an educating and informative episode of the Building HVAC Science Podcast. So listen in. Today, we have an honor of meeting with the man, the legend, Dick Kornbluth, to talk about the topic of radon, something he knows a lot about, I've come to learn. How you doing today, Dick?
I'm doing just fine. Thanks, Bill.
Some of our listeners might not be familiar with sort of who you are and what you do and what you've done over the years. Can you give us a quick summary of what you're all about?
Well, I live in Syracuse, New York, and in 1977, I joined a small retrofit installation company here in Syracuse. I left that company in 1980 with one of my partners in the original company and started Entherm, a retrofit installation company. And in 2001, when NYSERDA began the first Home Performance with Energy Star program, we were the first contractor recruited into the program by NYSERDA. In 2006, we were given an offer by a national startup in the home performance industry called Green Homes America, and it seemed like the right decision at the right time, and we sold our business to them. I remained on the staff of Green Homes America till 2010 when I left and went into semi-retirement. Since then, I've been doing some consulting work and I've been doing some training. I spend most of my time doing volunteer work, currently the board chair of the Building Performance Institute, and I'm on the board of the Building Performance Association and on the board of the New York State Building Performance Contractors Association. And I have been working with weatherization agencies in several states to implement the new rules from the DOE regarding radon work in the weatherization community.
Very good. So throughout all that time, you've amassed a lot of knowledge on the topics of buildings and building performance. And you're frequently a presenter at the Home Performance Conference, the national conference. I think that's where I may have met you first, or maybe through BPI, something like that.
That's probably the case. I've been presenting at home performance conferences since around 1994, 95, 4 or 5 or so. And I think I've only missed one national conference since then.
That's a lot of coverage. So let's talk about the topic of radon. That's the subject today. And you've done some great presentations. I've seen a couple. You've shared a couple with me. Let's go through for the listeners. What actually is radon?
So radon is an elemental, naturally occurring gas. It's generated by the spontaneous disintegration of uranium. All radioactive elements change into other radioactive elements. There's a well-known decay chain that's known for each radioactive element, and radon is simply one of the stages in the radioactive disintegration of uranium. It's found in certain rock formations, mostly in shales and limestones and some granites. and it's considered to be the second leading environmental cause of cancer after cigarette smoking in the United States. So it's chemically inert. It's actually does not react with anything chemically, which is part of the problem because it can travel unimpeded through the soil and get into houses where it can be breathed in and contribute to a lung cancer risk. The other thing to know about radon is that all radioactive elements have what's called a half-life, which means that they spontaneously decay, and it's decay at a very, very specific and precise rate. And what a half-life simply means is that if you have a pound of something, the half-life is the time it takes for that 1 pound of something to turn into a half a pound. So the radioactive half-life of uranium is several billion years. So if it's in the ground under your house, it's not going away. But the good news is that the radioactive half-life of radon is only 3.8 days, which means that if it's in your house and you seal your house up and hermetically seal it in 3.8 days, the radon will be reduced to half its strength. And then another 3.8 days, it'll be reduced to half again. And so eventually it will disappear from your house. So it's not a problem so much of having it in your house as it is keeping it out of your house.
Keeping it out. So you talked about the risk and you shared with me some brochures from the EPA. They have a home buyer's guide and a citizen's guide to radon. And just so people get an idea of the impact, you said the second largest to lung cancer. The numbers actually, and this is a 2003 data, I think, is 21,000 per year, deaths per year are attributed to radon, which at that time was more than drunk driving or falls in the home, drownings, or even home fires. So it's a tremendous thing that I think a lot of people aren't aware of.
Yeah, because unlike drunk driving and falls in the home, the effects of radon gas might not become apparent for 20, 30, 40, or 50 years. So it's not likely that anybody would associate the onset of lung cancer with some environmental event that took place in their house over the course of their life. Well, mostly because radon, being completely chemically inert and has no smell, no taste, no odor. So you could be living in a house with high radon levels for your entire life and have no idea that the radon is even there.
And it's a kind of time of exposure thing, like some other cumulative poisons. The more you're exposed to the higher levels, the more impact it has, negative impact.
Yeah, it's basically dose over time. If you want an analogy to radon, it would be cigarettes. So the risk of lung cancer from cigarettes is a function of how many you smoke and for how long you smoke them. So if you smoke one cigarette a day or one cigarette a year, your risk is lower than if you're smoking a pack a day. And the risk from radon is considered to be analogous to that.
Got it. Different levels of concern or different levels of interest. There's some US standards, some worldwide standards. What are the numbers that we're talking about? And also the units of measurement, so people can hear that too.
So the units of measurement for radon is called is picocuries per liter. And picocuries is a measure. The way you measure radioactivity is with curies. And picocuries is a really, really, really small amount of radioactivity. So it's essentially the amount of radioactivity given a certain volume of air. So it's picocuries per liter of air. The standard in the United States for action, according to the EPA, is 4 picocuries. So the EPA says that if the average level in your house equals or exceeds 4 picocuries per liter, you should take action to reduce the radon levels. There are different action levels according to different agencies. I believe that an agency of the United Nations actually has an action level of 2, and I think there are places in the world where the action level might actually be a little higher. What's important to note about the EPA action level is that that level 4 picocuries, when it was initially established back in the 80s, the early 80s, was not based on any epidemiological or medical research. At the time, it was based on a calculation by engineers about what would be a cost-effectively low level to achieve of radon in buildings. And that was based on mitigation technology that was way, way different than the technology that's around now. So the 4 is not sort of an absolute number that says that anything less than 4 is completely safe. It simply was an economic decision based on economic considerations.
That's revealing. That's interesting.
Yeah. When I first started, probably the second or third project I ever did was for the home of a nuclear engineer who was working on the 9 Mile 2 nuclear plant in upstate New York. And I asked him personally what he thought a safe level of radon was, and he said there is no safe level. So that was his opinion. But the EPA does say that you should attempt to get radon levels below 4 for sure, and ideally below 2.
And when we talk about radon, there's areas in which it tends to be more concentrated. I've seen various maps and things like that. Can you speak towards that topic?
Yeah, so the EPA has established a radon zone map, which is based on tens of thousands of measurements over the course of the last 20, 25 years. It's accessible by going to www.epa/radon, and I'm not sure exactly what the precise sub page is, but the EPA has divided the radon risk in the country into 3 zones. Zone 1 would be areas where the average radon level would be above 4. Zone 2 would be where the average radon levels would be between 2 and 4. And zone 3 would be where average radon levels would be below 2. If you look at the map, what's interesting is that most of the zone 1 areas are on the northern half of the United States. The southern states seem to have less risk associated with them. But the fact that you happen to live in a zone 3 area does not mean that on your particular house, on your particular street, that there is no risk. It simply means that it's a statistical average that the risks are lower if you live in a zone 3 area.
Yeah, so it doesn't mean you're radon free. And I think I've also heard that because your neighbor hasn't doesn't necessarily mean you have it in your house or the same kind of level. It's really got so many factors that are involved with construction. Is that true?
Yes, the fact is that you could have radon in your house at an unacceptable level, and your next door neighbor could have radon at an acceptable level. However, if you are in an area where radon is predominant, the odds are greater than 50-50 that your house will have a high level of radon. The main factors that determine radon levels in a house, interestingly enough, are not the construction of the house at all. The main factors that determine radon levels in the house are 2. One is the strength of the source, which means the actual uranium deposits in the ground. And the second biggest factor that determines radon levels in a house is the porosity of the soil, because the radon gas has to move through the soil to get into the house. And the wetter and more clay-like the soil, the more resistance there is to radon movement, and the drier and more loam-like, or if there's a lot of sort of glacial deposits, so you have a kind of very porous soil, then the radon can move much more quickly. So it's really the concentration of radon in the ground and the soil porosity, which are the major determinants of radon level in the house.
So with that being said, how does it get into the house and how does it concentrate? How does that happen?
All gases move by 2 fundamental mechanisms. One is diffusion and the other is pressure difference. While there is some very minor rate of diffusion that occurs through even a concrete slab, the major driving force for radon in the building is going to be pressure difference between the lowest level of the house and the ground. So if you have a basement, it's going to be the pressure difference between the basement and the ground. And what's interesting is that the pressure difference between the basement and the basement can be affected by other factors in the house, such as stack effect, et cetera. There are many factors that on a short-term basis will change the radon level in the house, even such things as barometric pressure, wind blowing against the house, anything that can alter the pressure of the air in the lowest level of the house with respect to the ground will have some effect on radon levels in the building. And what's interesting is if you do hourly measurements, if you take a continuous monitor and do hourly measurements of radon level in any building, anywhere, the radon level will actually fluctuate hourly. And probably if you were going to take measurements by the minute, you could probably see fluctuations by the minute. So over the course of whatever time period you're measuring, radon levels will literally fluctuate to some degree, minute by minute, hour by hour, even day by day, and even season by season. But they will fluctuate only within a certain range. So if your average level in your house is, for example, 15 picocuries, it's rare that it's going to drop below 4. It's rare that it's going to be increased above 20 or 30. So it'll vary within that range adjusted by the average. all of which means that you can't measure radon like a Geiger counter, where you just take a Geiger counter and get an instantaneous reading, simply because it would be completely unreliable. So the only way to accurately test for radon is with measurements that occur over a minimum of 3 days, which are called short-term measurements. Or if you want to get a yearly average, there are simple devices that will actually give you your exposure over the course of a period from 3 months to a year, which should be a much more accurate way of assessing your actual health risk.
You may or may not be aware, my company, True Tech Tools, sells some radon measurement devices. Actually, I just pulled one up on the screen. I have one in my office. I'm going to send you one. If you don't have one already, I got to send you one. This new one with the app in it is great, because I'm sitting here looking at the level changing between 5 about 3 weeks ago, and this week it's down to 0.4 was the lowest it's reached.
Oh, that's interesting.
And the monthly average is 1.9.
Did it rain last week?
It rained last week. Yeah.
Yeah. A rain can actually have a very significant short-term effect on radon levels. It's called a rain spike, but it's basically just a short-term effect that lasts a few days and then it goes away. Lots of theories about it, but one is that as the heavy rain hits the ground, it almost acts like a piston. As it saturates the ground, it pushes the radon into the building. That's kind of the current thinking about that. So rain can have a short-term effect. Wind has a short-term effect. Seasonally, there's some dispute about the seasonal effects, but it's generally believed that in the wintertime, radon levels tend to be higher than in the summertime, simply because of stack effect. As warm air rises through the building, it lowers the pressure in the basement, which causes more radon to enter the building.
I had another theory on that, just based on having this monitor for the last year or so, is frozen ground. If the water gets into the ground and freezes, that it also provides some kind of blockage to the flow of gas. That's just my personal theory, but for seasonal.
Yeah.
I want to take a moment and mention one of the sponsors of the Building HVAC Science podcast. It's Build Equinox. Build Equinox is the manufacturer of the Serve 2. That's the conditioning ERV. And of course, an ERV is an energy recovery ventilator. I like to call it a smart ventilator, as it decides when to run based on integrated sensors. This very unique product contains a 1/3 horsepower variable speed heat pump to positively transfer more of the sensible and latent energy between this ERV's ventilation and exhaust streams. I'm so impressed with this product, I'll be using it in my own personalized performance home scheduled for occupancy by summer of 2020. So surf on over to www.buildequinox.com to learn more about the Serve 2, which, by the way, is American designed and made in a solar-powered factory in Urbana, Illinois. Also look for an episode of the Building HVAC Science podcast, where I interview the inventor, Ty Newell. And when you get in touch, tell them the Building HVAC Science podcast sent you. Thanks. Okay, so we know how it gets in a general way. We know that it fluctuates over time. And I think that fluctuation over time speaks towards the need. You mentioned that there's no Geiger counter instantaneous test, but it speaks towards the needs for a long-term test. Any further discussion of why a longer-term test is necessary and you can't just walk in and read radon?
Yeah, so the EPA has established testing protocols for radon, and those are actually available by going to the EPA website. And basically, there's two general testing protocols. One is, interestingly enough, if you're selling your house, and the other is if you're not selling your house. So what the EPA says, if you're selling your house, you should test in the lowest level of the house that is suitable for occupancy. And what that means is that if you have an unfinished basement, but the basement is such that it can be converted into living space, the EPA says that's where you test. If you're living in your house and not planning to move, the EPA says you should test in the lowest level of the house in which you actually live. So if your basement is unfinished and you rarely ever go down there, then the EPA says you would test in the first floor of the house, for example. The other thing that they talk about is short-term testing. And what they say is if you use a short-term test, which is essentially a 3-day to 7-day test, and you get levels that are above 4, they recommend doing a second test. And if both tests show that the levels are above 4, you should take action. If you do a 3 to 7 day test and the level is below 4, the EPA says you're probably okay. If you are living in your house and not planning to move, however, your health risk is a function of your long-term exposure to radon, in which case doing a longer-term test might give you a more reliable indication of your health risk. And there's relatively inexpensive test kits called AlphaTrack test kits, which are designed to be deployed for 3 months to a year. And you could deploy those. And if you can remember to pack them up and mail them off to the lab after a year, they would give you the yearly average, which is a more reliable test for your specific health risk of exposure to radon.
Do you know how those AlphaTrack kits work?
Yeah, I do actually. What's inside an AlphaTrack test kit is a very, very thin sheet of plastic. And as the radon gas diffuses in and out of the test kit, it decays into charged particles, which are part of the decay chain of radon. And those charged particles literally burn a hole in the plastic, literally. And so when you send it off to the lab, they count the holes. It's pretty much that simple.
Wow. I never knew that. That's pretty amazing how that works.
Yep.
And generally, the listeners here are home performance or HVAC related industries. So, what do people in those industries do or should be aware of with regard to radon? Anything in terms of mechanical systems?
Yeah. Think about what causes negative pressure in a basement. And probably this absolute single biggest factor that causes negative pressure in a basement is a leak in a return duct. So anything that lowers the pressure in the basement, such as return duct leakage, can significantly affect radon levels in the basement. So anybody in the home performance business who's working in a forced air environment in houses, apart from all the other benefits of sealing up ductwork, should actually consider sealing up return ducts specifically because that is connected directly to risk of radon levels in the basement. The other thing to keep in mind is that if stack effect actually does have a significant role in radon levels, then lowering exfiltration, lowering air loss by sealing up the top of the building and reducing stack effect driven air leakage will also have an effect on radon levels in the basement. And finally, the other thing to consider is that air sealing the plane, the basement plane between the basement and the first floor is probably a good idea also. Interestingly enough, though, if you seal the rim joist, which everybody does for energy reasons, bringing outside air into the basement actually will dilute radon levels, but it's hard to say to what extent that factor can occur.
Yeah, so just another layer of kind of complexity to house as a system.
Yeah, very.
Have you dealt with mitigation systems or the kind of the correction systems that get put in? Do you have anything to impart there?
Yeah, I've done about 4,000 or 5,000 of them.
Okay, only 4 or 5. You barely qualify, but I'll let you go ahead. All right.
Yeah. So very simply, back in 1987, I live in an area that's Zone 1. And in fact, New York State Department of Health has been collecting radon test results in New York for over 20 years. They have a lot of data. And in my community, 60% of all the houses in my community are above 4. So it's really a radon-rich community. Back in 1987, I was recruited by an engineering firm that I had done some insulation air sealing work with them. They had a contract to do radon research, and they were contacted by a local homeowner who had a radon problem, didn't know where to go to. And they contacted me. They designed a system and said, could I install it? And I said, yes. I didn't know anything about radon whatsoever at that point. And serendipitously, about the same time, New York State had sent a couple of radon experts, including Terry Brennan, who many of your home performance people probably know, around the state to do training for mitigation. So I took a 3-day course with them, and then that got me knowledgeable about radon, and I started to do radon mitigation. I think I was probably the second person in the area to do any radon mitigation. Eventually, there was a national certification program created, and I got certified pretty early on. So in my insulation, air sealing, home performance business, I ran 2 separate businesses, a radon mitigation business and a home performance insulation and home performance business. So I got to do a lot of houses. I think probably we were averaging at least a house a day over for at least 10 to 15 years. So it became a significant part of my business.
And those systems, can you describe for our listeners how they work? What's the process of installing a system like that?
Yeah. So the principle of radon mitigation is that if you accept the fact that radon entry into the building is a pressure driven flow, then that means that the pressure of the soil gases underneath the slab is pushing toward the house at a higher pressure than the pressure of the air in the basement pushing back down. Then the best way to keep the radon out of the building is to reverse that pressure relationship. So if you can cause the pressure in the soil under the slab to be lower than the pressure in the basement, then that will stop radon from coming into the building. And that is done through a system that involves drilling a hole through the slab, digging out 5 or 6 gallons of dirt simply to create a large air pocket, installing a 4-inch PVC pipe or 3-inch or 4-inch PVC pipe into that hole. That pipe has to exit the building at some point because of standards for radon mitigation. And then inline in that pipe on the exterior of the building or in an attic or in a garage where that pipe is going, an inline centrifugal fan is installed. The pipe is then extended above the roof line of the building. And when that fan is turned on, it creates a vacuum or negative pressure under the slab, and that stops the radon from coming in. There are, obviously, if you're going to create a negative pressure, you can't leave any big holes in the slab because that's like short circuit in a wire. So part of the process is to seal up significant holes such as sump pumps and large penetrations of the slab, any kind of piping penetrations or significant cracks. But the system is really designed to address pressure relationships, and that's how it works.
That fan must be exterior or in what's considered an exterior space outside of the pressure envelope of the house or structure.
Yeah. So the EPA created the initial standards. There's an ASTM standard and a AARST, which is the governing industry organization standard. And the reason in the United States that they want the fans to be outside the living space is that between the fan and the ground, everything is under negative pressure. Between the fan and the termination of the vent pipe, everything is under positive pressure. So they simply said, we want all the piping inside the house to be under negative pressure. And that means if there's a leak in the pipe, nothing comes out. Air might go in, but radon doesn't come out. And so they wanted the piping to be negative in the house, which means the fan is not in the house. So that's the thinking, at least, behind that rule.
It makes sense. So, like we do sell monitors at TrueTech, but they're not monitors that are suitable for professional verification. And you mentioned AARST, and I had heard of that before. Does that organization certify individuals, or how does that work?
Certifies individuals for testing and mitigation both separately. So there is a testing certification through AARST and a mitigation certification through, and they are individual certifications.
To the person.
To the person.
Not the business.
Not the business.
Got it. And then the equipment that they could use, is there a list of equipment that's suitable? You mentioned long-term, short-term monitors, things like that. That's also an approved list that's created by AARST?
There's no particular list that AARST has for equipment. They don't address that specific issue. The issue about testing, short-term testing, is acceptable if you do it according to the protocols. So charcoal test kits, for example, or liquid scintillation test kits, the kind that are sold through big box stores, are okay to do initial testing. The advantage of continuous monitoring is that if you have one that actually could give you hourly readings, it gives you more information that you can use to actually determine what's going on in the building. So that's good. And then there are lower cost continuous monitor that will give you integrated averages over the whatever test period time you're testing at. And they're also reasonably reliable and useful. But in terms of the equipment to do the work, probably the single biggest piece of equipment that you need is a way to chop a hole through a concrete slab. So that's really the only real significant piece of equipment that you would need to do the radon mitigation work.
So one of the other things in some of the documents you share with me was radon in water. Can you talk a bit about that?
In rare instances, when there's well water, there can be radon in the water itself. The health risk of radon in water is not drinking the water, it's actually aeration, which releases the radon gas into the air. So, if you have a well and your water tests high for radon, the risk to you occurs when you take a shower or you are washing your clothes or your dishes or you're boiling water. Anything that will cause the radon to come out of solution in the water is where the risk is. Right now, I think the acceptable limit of radon in well water is like 10,000 picocuries per liter. So it's a completely different measurement than the measurement for radon in the air in terms of risk. The most acceptable way to mitigate the issue of radon in water is essentially a plumbing appliance that aerates the water before the water actually gets into your internal water distribution system and then releases the radon into the air. It's pretty rare to find radon in water as a health issue because it's specifically related to wells, individual wells, and is specifically related to very specific rock formations. But it does occur in some areas. I know that in downstate New York, there's a community that has a problem and they have a community well, and I believe they had to mitigate the community well. Up in the Adirondacks, way up north, we've encountered in the essentially 30 years, 28 years that I did radon mitigation, we encountered a water problem twice. So it's not common.
Not very common.
No.
One other thing that came up, which sort of made a difficulty in assessing radon, was for detection or mitigation, was something called karst topology. Can you talk about where that happens and the significance? I mean, like where regions where you'd find this topology?
So karst is really, really interesting. Karst is the radon mitigator's nightmare. So what karst is, it's a limestone. And if you think about limestone, all caves are limestone. So karst formations tend to have large channels through the rock formation. And what happens with karst and radon is that those channels, normally in a house where there's a radon problem, the source of the radon is directly underneath the house. And simply radon coming out of the radioactive decay of uranium diffuses through the soil and finds itself underneath the basement house and enters the house. In the case of karst, because you have channels through these rock formations, the source of the radon can literally be way distances away. And according to how the currents of subsoil air or whatever what you call it are moving through the limestone, you can have radon levels in a house that can be 100 picocuries per liter one day and be zero the next day. So it's a unique circumstance when there's karst formations under the house. Now, where karst occurs, it varies. It's all over the country. I've talked to radon mitigators that they have a problem in Kentucky, parts of Kentucky. There's a lot of karst in my neighborhood where I did radon mitigation. And the problem with karst is that, number one, it's really hard to get reliable readings because the readings can be profoundly changed from season to season and from day to day simply by the movement of air currents through the underlying rock formation. So measuring in karst formations is really hard, and mitigating in karst formations is even harder, because when you're trying to depressurize under the slab, you might be connected to all kinds of air channels through the karst, and it's very hard to get negative pressure kind of distributed throughout the whole slab space. In some rare instances where we had radon in karst areas, we actually had success by turning the fan around and simply pressurizing the ground.
Keep it out.
Which works great, but brings other problems into the building, especially in the wintertime when you're sucking 10-degree air out and blowing it through PVC pipe into the basement, and you have issues with condensation and freeze up and stuff like that. But karst is a very special case with very, very special issues around it. Now, I'm sure that you can find resources online to determine if there's karst in your area. And if you want to get into the radon business, you have to be very careful about doing warranties when there's karst work.
Got it. So we covered a lot of ground in our discussion today, and I really appreciate you imparting your knowledge and experience here for everyone, because it's a tough topic. It's a prevalent topic, and you don't know. You just can't tell unless you do some kind of test. If anyone wanted to get in touch with you, what's the best way, or how would you like to do that?
Best way to reach me is my email address, which is just my name. So it's Dick Kornbluth, my full name, which means it's DickKornbluth.com. Probably the best way to get in touch with me.
Very good. And any closing thoughts for our listeners on this topic, this important topic of radon?
I think that if the home performance industry is concerned with making houses healthy, safe, durable, energy efficient, the healthy part actually should be addressing the issue of radon in the buildings. And I think this is a potential growth opportunity for home performance contractors to add an additional service to their business, which can generate income, but more importantly, actually fulfills the mission of home performance, which is to make the building safe and healthy.
Very good. I love that spirit, doing good work for a good reason. That's fantastic. And you're a good man. Thank you for coming on today.
Hey, you're welcome.
Yeah.
Thank you.
We'll wrap up today and want to again thank Dick for coming on and talking about the topic of radon. We'll provide some more additional information in the show notes, some of the links to the EPA, Dick's email address, which he kindly offered to us, and a few other things to talk about. So read up on the show notes for more follow-up. Thanks again today, Dick. Really appreciate it.
You're welcome. It's been my pleasure.
I want to thank you for listening to this episode of the Building HVAC Science Podcast. Hope you learned some few things about radon. It's a very interesting conversation for me to have too with Dick. You can find other trade-oriented podcasts, Tool Pros, Service Business Mastery, HVAC School, part of the Blue Collar Roots Network by going to bluecollarroots.com. We're trying to do our part to help transform and professionalize the trades by filling the skills and the knowledge gap through training and communication. You can reach Dick, as mentioned in the show notes, at Dick, and in the episode, at dickkornbluth.com. That's KORNBLUTH.com. Also, if you're interested in any of the tools for measuring radon, test instruments for measuring radon, we have everything from residential detectors all the way up to professional level detectors. We have them at TrueTech Tools, my company. You can learn more if you go to this link, truetechtools.com/radon. That's TRUTECH tools.com/radon. If you like what you heard today and you've not yet subscribed to the podcast, please consider doing so by typing Building HVAC Science into the search bar of any of the typical podcast apps or services. The Building HVAC Science podcast is a production of TrueTech Tools Limited. In full disclosure, I'm a co-owner of TrueTech. The opinions voiced are those of my guest or myself, depending on who is speaking, of course. As always, we want to thank you for listening and hopefully following us on Facebook on the Building HVAC Science Facebook page. Clicking subscribe will help be sure you're up to date all the time, and it will really help our ratings in the eyes of Google and iTunes if you go in there and give us a review. Thanks again for listening to the Building HVAC Science Podcast.